an expression of the type e naught x raised to power n plus e1 x raised to power n minus 1 plus e raised to power n minus 1x plus en is called a polynomial. In the variable x with coefficient e naught, e1, en minus 1, en. These coefficient may be from set of real number, set of rational number, integer and other prescribed set. Okay, now if we see e naught not equal to 0, then the degree of the above polynomial, you can say 1, the polynomial 1 is n. Otherwise the degree of 1 is less than n. If e naught equals 0, e1 equals 0, finally en minus 1 equals 0, then 1 reduces to a constant polynomial. If an not equal to 0, if an equals 0, 1 is called 0 polynomial. Already, that is, all terms are 0, 0 x raised to power n, 0 x raised to power n minus 1 plus 0 x plus 0 equals 0 polynomial. 0 polynomial. The degree of 0 polynomial is not defined. Now we consider two results. First is a remainder theorem, and second is factor theorem. Before this, we would like to tell that a polynomial e naught xn, e1 xn minus 1, en is usually denoted by fx. Denoted by fx. If the degree n of fx is 1, fx is called linear, and it is of the type, that is, fx is e naught x plus e1. If n equal to 2, fx is called quadratic polynomial, and in that case fx is of the type plus a2, a naught not equal to 0 here, a naught not equal to 0 here. And if n equal to 3, fx is called cubic, in this case fx is a naught x cube plus a1 x square, a2 x plus a3, and so on. We can determine more degree polynomial in this way. Now first we remainder theorem. For any polynomial fx and gx, there exist two polynomials qx and rx such that fx equal qx gx plus rx, where rx is zero polynomial or degree of rx is less than degree of gx. That can be verified easily, this result. If we take two polynomials fx and gx, then we can find another polynomial qx and rx known as quotient polynomial, and this is remainder polynomial. Then property of remainder polynomial is more important here. Either remainder polynomial is zero. If remainder polynomial is zero, then we say that gx divide fx. So if rx is zero, we say gx divides fx, and we denote this fact by writing gx divide fx. If rx is non-zero, then degree of rx is less than degree of gx. In particular, if gx is x minus a is a constant, then degree of rx is less than 1, that is 0, and therefore rx is a constant. Say r, a constant, because degree of rx is less than 1. So less than 1, because degree always a non-negative quantity, then it is 0, only choice, and 0, and we have already taken that it is a non-zero quantity, so this is a non-zero r. So in this case, from this expression second, fx can be written as fx equal qx x minus a, as we have taken gx x minus a plus r. Plus r. So the remainder theorem is if fx is a polynomial, then fx can be written as qx x minus a plus fa. Fa is called the value of, this is called the value of fx at a, that is x equal to a, value of this polynomial at a. For example, if you talking about the value, so you can say fx is 3x square plus 2x minus 1, like this. So f2 is here 3 2 square minus 2 2 minus 1, and this is 4 3 are 12 minus 4 minus 1, this is 7 here. So this is the value. Okay, in this way we can determine the value of this. So we can prove this fact easily. Proof: if As we have seen, in this 3, fx is qx x minus a plus r, where r is non-zero as we have taken already, or maybe 0 according to this choice. Now putting x equal to a, we get fa equal qa a minus a plus r. We see that a minus a is 0 here, so we get fa equal r, and then we get the remainder theorem here. R can be replaced by fa, and we have this remainder theorem. Now we comes to factor theorem. Factor theorem. First of all, before define factor theorem, a number or constant, you can say constant a is called a root of fx if fa equals 0. We know about the fact. So now factor theorem is a is a root of fx if and only if x minus a divides fx. So proof is here again from the fact that if the terms remained by remainder theorem, fx can be written as qx quotient x minus a plus fa. If a is a root of fx, then by definition, this is definition, fa equals 0, and that implies fx, this from expression 4, you can write from expression 4, we get fx equal qx x minus a, and this is 0 now. So that is by definition x minus a divides fx. This is remainder theorem one part, factor theorem one part. Now we can take conversely. Let x minus a divide fx. X minus a divide fx. Then clearly from this expression 4, from 4 fa equals 0, because if it divides then remainder must be 0, and that implies a is a root of fx. So these two results are very easy but have important applications in mathematics, and these applications required division by x minus a. So division of a polynomial by x minus a. Now we will deal and describe synthetic division. So we have studied division of this. If we want to divide 4x cube minus 2x square plus x plus 1 by x minus 2, Then by long division method or school book method, we will have such thing. X plus 1 we will write like this, x minus 2. Now x 4x square, 4x cube minus 8x square minus, this is plus, and this is 6x square plus x plus 1 now, and this is 6x square minus 12x minus plus 13x plus 1, and now plus 13x minus 26 minus plus, this is 27. Now we see that remainder is 27 and quotient is 4x square plus 6x plus 13. So in this way we find remainder and quotient of this by long division method. But it is not very much practical method when its degree is 4 or higher degree. So we discuss here a practical method due to synthetic division method. So if you use synthetic division, techniques, so how we can use synthetic division to determine quotient and remainder? First of all, write this equation without writing x. So this is a 4 minus 2x 1, sorry, there is a 1, coefficient of this 4 minus 2, here is 1 and this is 1. We write like this, and we want to divide by x minus 2, so write here 2 here. Now write straight way 4 here and multiply this 4 by 2, so 4 2s are 8 and write 8 here. So you will get here 6. We add this after adding with this here, adding, we get this. Now again multiply this with 6, 6 2s are 12 and write here 12 and adding this again, this is 13, and now multiply this 26 and adding, this is 27. So this is a remainder terms and this is a quotient 4x square plus 6x plus 13, because here there are 4 terms because of degree 3 and there are 3 terms because of degree 2. So this is quotient and this is remainder. So synthetic division is quite useful to determine remainder and quotient of a given polynomial. Now we take another example. If we take a polynomial fx is 4x4 minus 5x cube plus x 2x minus 7 if you take, and we wish to divide this by if you want to divide by x minus 2. X minus 2 already we have taken, x minus 3 if we want to divide. So by a remainder theorem, we can say remainder of this is f3, and we can compute 4 3 raised to power 4 minus 5 3 raised to power 3 plus 2 into 3 minus 7. We can find a remainder using this technique, or you can see here remainder is, so now you can write 4 into 81 minus 5 into 27 plus 6 minus 7, and this will be a amount that will be 81 4s, this will be 324 and this is 27 5 135, and this is minus 1, so you can say 324 plus minus 136, this is 188, this is a remainder. So we can find directly remainder. Here we also can find remainder directly using remainder theorem. If we write fx is 4x cube minus 2x square plus x plus 1, as we have already, this is polynomial 4x cube. So we can find remainder here 4 f2 by direct remainder theorem. So this is 8, and this is 4 plus 2 plus 1, and this is 32, and this is 8 plus 2 plus 1, so this will be 35 minus 8, this is 27. We can find directly the remainder. So there is a computation of power, we need computation of power. So you can see here also we computed power of this. Now we can determine this is the only way to determine remainder, but it doesn't figure out quotient of this. But in case of synthetic division, we can also figure out the quotient of this. So now we can see here, if fx is this, 4x4 minus 5x cube plus 2x minus 7. Okay, so first of all, you see that this polynomial is not complete, it is incomplete. Why it is incomplete? Because there is a power of 4 is a coefficient of x raised to power 4, minus 5 is a coefficient of x cube, but there is a no terms containing x square, so we write 0 instead of that, and 2 and minus 7 before applying synthetic division. Okay, so we will make it complete by adding this plus 0x square. So because it has power 4, a 4-degree polynomial, so in a complete polynomial there will be 5 terms. So we should careful about before applying this synthetic division, there must be, if degree is 4, then there must be 5 terms, and there is a degree 7, then there must be 8 terms. So now we wish to divide by x minus 3, or you may take x plus 3, you may take x minus 2. So if you take x minus 3, so this, so 4 is here, 4 3s are 12, and there will be 7 21, there is a 21, 63, and this is 65, and finally we will get here 5 195, and there will be 188. This is a remainder, and the quotient is this. So this is a much easier than this computation. Okay, so synthetic division is very useful tool, and I hope student have learned about synthetic division. Now I will take another example. This will be the last example. This will be the third one. Fx, if you take fx is this, fx is 4x 2x 4 minus 3x square plus 3x minus 2. This is, and we wish to divide by x plus 2. So division by x plus 2. So we will determine quotient and remainder. remainder we can find directly f minus 2 here by substituting x equal minus 2, because we are considering x plus 2, so root of this is minus 2, so we substitute, we are here minus 2, and you will get 2 minus 2 raised to power 4, 3 minus 2 raised to power 2, 3 minus 2 minus 2, that will be a remainder here. And that will be remainder. This is 32 minus 12, this is 20, 20 minus 6 is 14 minus 2, this is 12. So now we how we determine the remainder and quotient by synthetic division, we will see here. Okay, so first of all we write a complete polynomial. So complete polynomial here 2, and we see here power of x, x cube is not there, so we will take 0 here, and minus 3 coefficient of x square 3 minus 2, and here x plus 2, so root of this is minus 2, so we will divide minus 2, so 2 is here, 2 2's this is minus 4 here, so there is a minus 4, this is 4 2's are 8, and this is 5, and 5 2's are 10, this is minus 7, and this is a 14, and this is 12. So this remainder is 12, and quotient is here 2x cube minus 4x square plus 5x minus 7. This is a remainder. In similarly we can divide from 3x plus 2, like instead we writing this, we will write this 3 taking common, x minus 2 by 3, x plus 2 by 3, and we will use synthetic division for minus 2 by 3. So minus 2 by 3, in this case we use synthetic division, minus divide by minus 2 by 3, here minus 2 by 3, so that will be a much complicated computation point of view, because we are dealing with a rational number. So here is 2 as it is, this is minus 4 by 3, and this is minus 4 by 3, and we multiply this, and this becomes some complicated, so we should take care about synthetic division when we try to apply it. So it is better to this part should be a integer. Okay, thank you.